Remote sensing is a field of study that allows us to gather information about the Earth's surface without physically being there. There are two main types of remote sensing: passive and active. Passive remote sensing detects energy that is naturally emitted or reflected by the target. This energy includes visible light, infrared radiation, and microwaves. Satellites and sensors can detect this energy and use it to create images and data about the target. An example of passive remote sensing in action is the Landsat program, which has been collecting images of the Earth's surface since 1972. These images are used to study land use, urbanization, and other environmental changes over time. Passive remote sensing involves sensing radiation emitted or reflected by the target object or environment without actively transmitting any signals. Some examples of passive remote sensing include: satellite imagery is a common form of passive remote sensing, which involves capturing images of the Earth from space without any active involvement. These images can provide information on climate patterns, vegetation cover, land use changes, and water resources. Thermal imaging. Infrared cameras sense the heat radiated by objects and use it to create images. Infrared cameras used in thermal imaging systems can detect heat radiation emitted by objects, making them useful for detecting hot spots in buildings, in power plants, and electrical systems, and for mapping forest fires. Visible and near-infrared (VNIR) remote sensing. Cameras and sensors detect the visible and near-infrared light reflected by the target object or environment to generate images or maps. Microwave radiometry. Microwaves emitted by the Earth's atmosphere and terrain are sensed to study atmospheric and land surface properties. Passive acoustic remote sensing. Acoustic signals such as animal calls, bird songs, and ocean waves are sensed without any active acoustic source. Microphones and sonar detectors are used in passive acoustic remote sensing techniques to detect sounds made by animals, including whales, dolphins, and bats, for studying wildlife and their habitats. Passive atmospheric remote sensing. Radiation emitted or absorbed by the gases in the atmosphere is sensed to study atmospheric chemistry, weather, and climate. Passive radar is a form of remote sensing that uses signals from commercial broadcasting and other communication systems reflecting off objects, such as airplanes and ships, to detect their locations and movements. Explanation of active remote sensing. Active remote sensing uses a device to emit energy and detect the reflected energy. This energy includes radar waves and laser beams. Radar and LiDAR, laser radar, are examples of active remote sensing devices that emit energy and detect the reflected energy. An example of active remote sensing in action is the use of radar to study the Earth's surface. Radar can penetrate through clouds and vegetation, making it useful for studying areas that are difficult to see with other types of remote sensing. LiDAR, light detection and ranging system used to measure distance to a target using laser light. Radar, radio detection and ranging system used to detect the presence and movement of objects by transmitting radio pulses and measuring the reflection. Sonar, sound navigation and ranging system used to measure distance and locate underwater objects using echoes of sound waves. Advantages and disadvantages. Both passive and active remote sensing have their advantages and disadvantages, and each is best suited for different types of applications. Passive sensors have the benefit of relying on the sun's light to illuminate the target and hence do not require their own energy source, making them simpler equipment in general. Passive remote sensing is best suited for studying the Earth's surface during the day when there is sunlight available to reflect off the target. It is also useful for studying the thermal emissions of objects during both day and night. Thermal imaging is an example of passive remote sensing that can detect temperature differences and provide insight into the heat distribution of the Earth's surface. Passive remote sensing, measuring the Earth's energy that is naturally emitted or reflected without externally induced energy, has several advantages. Cost-effective. Passive remote sensing can be conducted using affordable equipment as it does not require any active sensors or transmitter. Wide area coverage. Passive remote sensing can provide information over large areas at once, allowing researchers to get a complete picture of the target. Non-invasive. Passive remote sensing does not interfere with the target as it involves the measurement of naturally emitted or reflected energy, making it suitable for observing sensitive ecosystems. Long-term monitoring. Passive remote sensing sensors can operate continuously over long periods, making it possible to monitor changes in the environment over months or years. Availability of historical data. Passive remote sensing has been in use for decades, and there are large archive data sets available for historical analysis and comparison against current data. As active sensors produce their own radiation and do not rely on sun radiation, they are daytime independent and can also retrieve information about the Earth's surface by night. Furthermore, depending on the considered wavelength, active sensors are weather independent. Active remote sensing, on the other hand, can be used day or night and can penetrate through clouds and vegetation, making it useful for studying areas that are difficult to see with other types of remote sensing. High spatial resolution. Active sensors have high spatial resolution, which means that they can detect small details on the ground or in the atmosphere. This makes them useful for mapping and monitoring applications. Can provide information about the composition of objects. Active remote sensing can provide information about the composition of objects, such as the chemical content of the atmosphere or the moisture content of soil. Can provide real-time data. Active sensors can provide real-time data, which is useful for time-sensitive applications, such as monitoring natural disasters or tracking the movement of ships. Conclusion. By combining the use of both passive and active remote sensing, we can continue to expand our knowledge of the Earth's surface and make informed decisions about how to best protect and preserve our planet for future generations.